Welcome to Unit 2, Lesson 14, Solving Systems by Elimination, Part 1. Our learning goal today is to investigate how adding or subtracting equations can help us solve systems of linear equations. We have two learning targets for this lesson. Number 1, I can solve systems of equations by adding or subtracting them to eliminate a variable. Number 2, I know that adding or subtracting equations in a system creates a new equation where one of the solutions to this equation is the solution to the system. Our first glossary term for this lesson is elimination, a method of solving a system of two equations in two variables where you add or subtract a multiple of one equation to another in order to get an equation with only one of the variables, thus eliminating the other variable. The next glossary term, solution to a system of equations. A coordinate pair that makes both equations in the system true. On the graph shown of the equations in a system, the solution is the point where the graphs intersect. The next glossary term, substitution. Substitution is replacing a variable with an expression it is equal to. Next glossary term, system of equations. Two or more equations that represent the constraints in the same situation form a system of equations. Our first practice problem for Lesson 14 asks, which equation is the result of adding these two equations? So if we look, when we add a system of equations, we are going to add in columns. So we're going to take negative 2x plus 3x, which equals x. Then we're going to take 4y plus negative 10y, which is going to equal negative 6y. And finally, we're going to take 17 plus negative 3, which equals 14. So we're looking for x minus 6y equals 14. And the only one that correctly identifies it is choice C. If you have any questions about how to add a system of equations, please use class time to ask for further clarification so that you are prepared as we move forward. Practice problem number 2. Which equation is the result of subtracting the second equation from the first? Again, we're going to do this in columns keeping the like terms together. So we're going to have 4x minus negative 5x. Minus a negative becomes a plus. So this becomes 4x plus 5x, and 4x plus 5x is 9x. Next, we're going to subtract the y terms. We have negative 6y minus 2y. And negative 6y minus 2y equals negative 8y. And finally, we're going to combine the number only portion. We have 13 minus 5, and 13 minus 5 equals 8. So when we put these back together, we have 9x minus 8y equals 8, and D is the answer that matches. If you have any questions about how to subtract a system of linear equations, please use class time to ask for further clarification so that you are prepared as we move forward. Practice problem number 3. Solve this system of equations without graphing. We're concentrating on the elimination method. And if you look at this system, what I want you to notice is this portion right here with plus 2y and negative 2y. If you have opposite variables, use addition to eliminate them. So here we're going to have 5x plus 5x equals 10x. 2y minus 2y equals 0. And 29 plus 41 equals 70. Now that we have 10x equals 70, we can divide both sides by 10 to eliminate it from the left, and we know that x equals 7. Now we need to find y. You can substitute 7 into either of the equations in the system. I like working with positive variables, so I'm going to use the top equation. This becomes 5 times x, but instead of x, we're going to use 7. Plus 2y equals 29. 5 times 7 is 35. Now we subtract 35 from both sides. This gets rid of it on the left, and we have 2y equals 29 minus 35 is negative 6. Divide both sides by 2 to get rid of it on the left, and we have y equals negative 3. Now that we know x and we know y, our answer is the point 7, comma, negative 3. This is the point where these two lines will cross on the coordinate plane if you graph them. If you have any questions about how to solve a system of linear equations using the elimination method, please use class time to ask for further clarification so that you are prepared as we move forward. Our last practice problem on lesson 14. Here is a system of linear equations. 6x plus 21y equals 103, and negative 6 plus 23y equals 51. Would you rather use subtraction or addition to solve the system? Explain your reasoning. What I want you to notice are the x terms. We have positive 6x and we have negative 6x. Remember what I said before. If you have opposite variables, you add the equations together to eliminate them. Now the question doesn't ask us to solve it, but just to give more examples of how you go through this process, I'm going to go ahead and solve it. 6x minus 6x, or plus negative 6x, becomes 0. 21y plus 23y becomes 44y. And 103 plus 51 becomes 154. Now, we have 44y equals 154. We divide both sides by 44. This gets rid of it on the left, and we get y equals 3.5. Now that we know what y equals, we can substitute that into either of the equations and solve for x. I like to use positive variables, so I'm going to use the top equation. We have 6x plus 21y, which we just said was 3.5, equals 103. 21 times 3.5 is 73.5. Now we will subtract 73.5 from both sides to eliminate it from the left. And we end up with 6x equals 29.5. Now we divide both sides by 6 to eliminate it from the left, and we get x equals 4.92. We'll round it. So these two linear equations will cross at the point 4.92, comma 3.5. If you have any questions about how to use addition or subtraction to eliminate one of the variables to solve the system of linear equations, please use class time to ask for further clarification so that you are better prepared as we move forward to lesson 15.